and we check the system behaviors. At the structure based, we go into how the system has been built, and in experience based, it's primarily based on the understanding of the system experience and educated guesses about bugs or so we'll go through all of these techniques one by one. Before we go further into it, there's a very simple example of the difference between black and white box. Many people say white box we can see inside the box, black box we cannot see, and many people get confused with this. A simple idea is that when I enter say 2 and another 2 in my calculator, I get an answer as 4. My black box will tell me that I get answer as 4. My white box will tell me is it 2 multiply by 2 or 2 plus 2. So black box is more of the behavior of the system, where expected behavior was for the system to give me 4, while as at white box I check how the system is built, the way the system is working for me. Let's go into black box techniques. The first and the most widely used technique is equivalence partitioning. Equivalence partitioning is little simple. It says you check your data. If the data's output is same, you put that data into one equivalence partition. You take one number from the partition and you assume that all other numbers will give you the same result out of that partition. For example, to make it very easy, if my one hand is able to do something, my other hand will also be able to do something. So if I can write with my right hand, I will definitely be able to write with my left hand. Chances are my handwriting will be very bad with the hand that I don't use primarily, but it doesn't mean that I cannot write. Instead, if there are some certain exceptions, no doubt. So say you have a text box which takes age as the field. So 1 to 100, if I can enter 1 as age, I can enter 100 or any other number between 1 to 100 as age. I assume that all the numbers between 1 to 100 will give me the same kind of result. Many people use it. We'll see some examples on it. Same goes with boundary value analysis, which says bugs are generally at the boundaries. So it is important for testers to test on the boundaries. Many people get confused with this greater than equal to kind of, less than equal to kind of logic, and many programmers do mistake there. So you have to check as a tester on these boundary values. So there are typically 4 values that people will check: minimum -1, maximum, and maximum +1. Again, taking that age example, 1 and 100. So my boundary values become minimum, which is 1, minimum -1, which is 0, max 100, and max +1, 101. So 0 should give me an invalid output or error or something. 101 should give me an error, while as 1 and 100 both should pass. Now, having said that, when I read this boundary value analysis and equivalence partitioning for the first time, I saw ambiguity. The ambiguity was, my equivalence partitioning says if one number from the group passes, all other numbers should pass. Boundary value says no. Boundary value says no. If there is if one is passing, 100 might fail. This means that either one of them is wrong. But no, actually both are correct. So I asked one of the experts, Vipul, one day, why there's ambiguity. And Vipul answered me, whenever you have a data which is in a continuous form, you should use both boundary value analysis and equivalence partitioning to make sure that everything is passing. So whenever you have a standard set of inputs, say 1 to 100, a continuous scheme, you should use both of them. Now this is very simple. Beyond boundary values and equivalence partitioning, this is just what books say. But beyond this, how to find this conventional BVA? For example, you should check for the behavior where the behavior is changing. For example, the boundaries where behavior is changing from one boundary to another. For example, if you have a text box which can show 5 characters at a time, but user can enter up to 10 characters, the behavior of the system will surely change when you enter the 6th character. So there might be a scroll bar which will come. Now you can move between that text box using your arrow keys or something. Just a very simple example. And the behavior of the system will change when you enter this sixth character. Now this is one behavior of the system which got changed. Or when you click print command of a system, the behavior of the system changes because it tries to find different softwares for the printers which are available on your system, and if it cannot find anything, it tries to find that should I print to file or something like it. So the system's behavior has changed. These are the places where we should do these boundary value analysis. Let's see some examples. First one, a simple one, as I told you, 1 to 99. So your three equivalence partitions here are 0 or any number less than 0, then a valid partition which is 1 to 99, any number between 1 to 99 both including, and the third one will be 100 or any number more than 100. Your boundary values here will be 0, 1, 99, 100. Going a little complex. Say you get average temperature on a system where the average validity of the temperature is from minus 99.99 to 999.99. Now here you can see the numbers are changing by some decimal points here, and it is not minimum or minimum minus 1 and max plus 1, but here the situation is where we are checking minimum minus 0.01 and max plus 0.01. So it depends what kind of input data you are getting, and you should add that one accordingly. Anyways, when I see this average temperature example, I always get a question in my mind. So I'm asking you, you don't need to answer me, but you can just think of it, at your own ends. Say I am sitting in Delhi right now, and say today's temperature in Delhi is 20 degrees Celsius, and tomorrow will be double hot. What will be the temperature tomorrow? If you answered it, you might have answered it correctly. It will be 40 degrees Celsius. Good enough. But the real question is this. If today's temperature in Delhi is 0 degrees Celsius and tomorrow will be double cold, what will be the temperature tomorrow? Now don't think for much. Double of 0 degrees is still 0. So what you do is you convert the 0 degrees Celsius into Fahrenheit, find the half of that Fahrenheit, convert it back into degrees Celsius, and you get an answer. So in software testing, even 0 has a half of it, which is not 0.0 in our case, or half a 0 in our case, but it will be some temperature. The example was just to tell you that there is always a solution for every problem. But the guys who are married, there is always a problem in every solution. Okay, going further. Sometimes you have some inputs like password, which is 6 to 10 character alphanumeric. You can use a XY chart here where you can see that I have this 6 to 10 alphanumeric characters on one side and put all these alphanumerics in another group in another side. So what you have is this all becomes your valid set, and these all are your invalid sets. So you have many boundaries here. Now you can check all this becomes your boundary, and you can check at any boundary. So this will give you a very good way of identifying a lot of test data. Depends on you how much test data you want to use out of this particular case. Or there are sometimes few examples where boundaries are dependent on each other. For example, in the date field, if it is MMDDYY 12 or 13 valid or invalid, 28, 29, 30 and 31 for a date in the month is valid or invalid depending on the which month you are talking about, and 28 or 29 for Feb becomes valid or invalid depending on the leap year. Okay, just to add up to another example or another question. How many months you have with 28 days in a year? My friends, if you said 1, then remember there are 11 months with at least 28 days in a year. Okay, so 1 with only 28 days. How many with 31 days? Think of it. You can use your hand, the good old, old-fashioned grandmother, grandfather type of counting. So when I counted it using my hand, I can get 7. So 7 plus 1 gives you 8. How many with 30 days? Now if you answered 4 or 5 is again wrong, because there are 11 months with 30 days. Okay, as testers, see from a very broad perspective. Same goes with your time. 12 or 13, if you're using a 12-hour clock, becomes valid or invalid. If you're using a 24-hour clock, always remember after 23, 59, 59, the next number in the series which is valid is 000000 and not 240000. If you're dealing with date and time, always remember that there is something known as that in Western countries you add and subtract 1 hour twice a year. If you know the name, daylight saving. So whenever you are testing with this time and date, always remember that daylight saving and don't confuse yourself. You will get a lot of bugs on that daylight saving, especially server times and all that if they are not being configured properly. Currency, again, you can see we are adding 0.01 here instead of 1 because currency goes in rupees and paisa, euros and cents, pounds and something else. I don't remember what use with pounds, but dollars and cents again. So you generally have dollars and cents going together, or rupee and paisa going together. So you add 0.01 paisa to make the boundary values here. The next is use case testing. Again, use case testing is where you have different workflows or you have different use cases, and you use these use cases and make sure that your system is conforming to those use cases. So you use, say, for example, I have given an e-commerce purchase example here, where customer places items in the shipping cart, selects checkout, and then confirms order for the delivery. Exceptions is customer attempts to check out with an empty shopping cart, or provides invalid address or invalid payment details. System gives error messages as appropriate, or customer has a 10 minutes of inactivity. All these are different exceptions. So use case testing is typically done when you are quite close to the end of your system testing and you are almost moving into your UAT cycle. So this is kind of business flow or end-to-end kind of thing that you will do in use case testing. If I add these use case and boundaries, I have few questions for you guys. I will not answer it, but these questions are for you. For example, is accepting a ridiculous input a bug? Now this is up to you. You can answer it the way you like. Okay. So okay, so people have already answered me a lot of things. So okay, there is one question that has come up from Ashish Setia. Which one is written first, use case or test case? Okay, Ashish, I will not answer this, but typically, okay, even as use cases are typically which are written during requirements, and test cases are written when you follow these use cases. So I think you get your answer on this. Okay, the next technique is decision tables. I'll straight away take you to an example of decision table and let us see what these decision tables are. Decision tables are typically based on the truth tables that you might have seen during your engineering or your MCAs when you were dealing with electronic designing. Decision tables were the truth tables were typically input of 1 and 0 and outputs were 1 and 0. So Boolean kind of thing. The same goes with the decision tables here that we use in software. What you have is you have a conditions that you will give to the system, the action the system will take, and these different columns of 1, 2, 3, 4, and 5 that you see talk about different business rules that your application is using. For example, I have used the ATM decision table here, which says if my valid card is not valid, the action the ATM will take will reject my card. Business rule 2 says if my card is valid but my PIN is not valid, system will ask me to re-enter the PIN. Third business rule says if my card is not valid, if my card is valid, my PIN is invalid and I have inputted my PIN invalid 3 times, system will keep the card or will lock the account or whatever. The fourth rule says if my card is valid, PIN is valid, but balance is not okay, system will ask me to re-enter. And last is if my balance is also okay, system will dispense the cash. Very, very simple ATM decision table. I just made it so that you guys can understand how this works. For example, there is a very famous example of the triangle that you enter 3 sides of the triangle and you get the output as isosceles, equilateral or scalene kind of thing. Then conditions in that case will be the first rule of the triangle. Is sum of two sides greater than the third side? That becomes my one condition here. The second condition will be all three inputs are integers or not, and they're two positive. And then if everything is okay here, then my third condition will be isosceles, equilateral, or something, you know, all three sides equal. And actions will be either error, isosceles, equilateral, or scalene for the triangle, if you know that particular example. Now this is a decision table where all these different business rules are dependent on the previous rule. For example, I cannot check my PIN if my card is not valid. Now how this helps? This helps you and these decision tables help you in writing, you know, you avoid writing foolish test cases. For example, if my card is invalid, I don't really need to check whether my PIN is valid or invalid. Same goes with your username and password. If your username is invalid, you don't really need to check whether your password is valid or invalid. There are some decision tables which are interdependent of each other. For example, if I change this to a banking decision table, and if I check about the interest rate of different interest rate for different people, my conditions will be whether there is a senior citizen or a normal citizen. For a normal citizen, I will have a separate decision. For a senior citizen, I will have a separate decision. Then I can have the time. So are you depositing your money for 1 day, 15 days, 45 days, 91 days, and so on and so forth. So this will all influence your interest rates. So you can see in this case, all the decisions that the system is taking are interdependent of each other. They are not based on some previous condition. So there are many decision tables you can use, first hit, multi-hit, or left hit, first hit kind of thing. There are so many different decision tables. You can get a lot of information over the internet about decision tables. One of the very easiest ways of identifying all the conditions of your system and creating test cases out of these. So now you can see for this particular decision table that you're seeing on the screen, you can create a lot of test cases. For example, for the first condition, you can create, if my card is valid, expected result, system should. If my card is not valid, system should reject card. If my card is valid, system should not reject the card, and system should ask me to enter the PIN or something. So you can have a lot of test cases coming out of this decision table. Typically, there's a crude rule which is not always correct, that typically your conditions, if you have 2 raised to n number of test cases coming out of a decision table where n is the number of conditions. The second is another technique is finite state models, where what you can do is now I have shown you an example where what you can do is you can create a state transition diagram for your requirements. Once you create these diagrams, you can identify a lot of problem areas in your state transition or in your designs. For example, I have made a point of sale system for you where the clerk logs in. If password is invalid, error is displayed. If password is valid, a register is opened where the system is waiting for the customers. When customer comes, the scanning starts happening, system goes into the scanning state. If scan is invalid, system asks the user to check it. If there are more items to be scanned, system displays a subtotal. When the last item is scanned, system goes into the charging state. If charging is valid, issues receipt and starts waiting for the other customer. If pay is invalid, error, end of the day, you close it, log it out, and that's it. Few things to remember: start state, initial state indicator, event, condition with that event, action the system will take, and these are different states that you can see, these small circles, and different transactions that you see. Very easy to identify bugs here. For example, if no customer comes in the entire day, poor clerk has to buy something to come out of the and close the register. As you can see, the only way to come out of this system is through the charging state. So I identified a defect right here. So there should be one transaction which goes straight from the waiting to logging out stage. So there are many other such defects in this. Very easy to identify it using a state transition diagram. Based on the state transition diagram, you can also create state transition tables simply by saying, taking the first state, logging in, then checking the event, which was password, action is error, new state is logging in. You can also identify a lot of negative test cases here. For example, at the logging in state, If my event or condition is customer, my action for the system is undefined and new state is undefined. So you can create this complete state transition table, and for all the actions and new states which are undefined here, you can go back and ask your analyst what if kind of questions for all these current states and events where your action and new state is not defined. Okay, going to white box. White box, you will have different coverages when you are checking the code. For example, you can have statement coverage, branch coverage, condition coverage, decision coverage, and all that stuff. That statement coverages where every statement, you can see right on the top, statement coverages where every statement must be executed in the code. Branch coverages when every branch is taken each way, true or false. Condition coverages where every condition has been evaluated. We'll go through all of them using an example. So I have given you an example of a factorial program. Very simple C program. I use three variables. I enter n. If n is less than 0, I print that this is an invalid number. Else, I take that number, put it in a loop, find the factorial and return it out. Now, if you see this program, how many values of n is required to cover all the statements here? Okay. How many values of n we require to cover all the statements? Only the statements. So I can use two values where n is less than 0. So we'll come here, we'll go with n less than 0 into this, we'll come out, print, return n, and that's it. We still have this else part remaining where we have not executed these statements. So we will use any value of n which is greater than 0. We'll go into this loop for the second run, and with these two values, say 5 and minus 5, we will execute all the statements of this program. So my statement coverage will be complete with only two values. But what about the decision coverage? Now, if I take you back, I told you in decision coverage, which is also known as branch coverage, every branch or decision is taken each way, true or false. So when I check this, have I covered all my decisions? Now, if I look at this program, there are two decisions. One is this if and else, and another decision is this I less than equal to n. So these are the two decisions. With these two values, I can cover the true and false side of if, but I have not covered the true and false side of if. Because when I give any value which is greater than 0, the control comes here, but then this will always be true. In order to have this false, I need a third value where I need to give this n as 0 and nothing else. So the only value of n which will check the true and false will be 0. Okay, so three values for branch coverage. Branch coverage will be where I'll check the true and false of all the branches or all the decisions that I have in my program. There are no condition coverages here. I'll give you an example of condition coverage, don't worry. And for the loop coverage simply says you go inside a program one time and you cover that particular loop maximum times. So for this particular case here, for this particular for loop here, you go inside the loop once by giving a value of n as 1, and then you give the value of n as say maximum 100 or 150 or anything to just check that whether this loop is not entering into a infinite mode. Let's see what is a condition coverage. I have taken an example of a female getting married in India. So according to laws, if a female age is greater than 18, she can marry. So you can see I have used gender on one side, age on another side, and can marry question on the third column. So yes is only at one stage where you have female is greater than 18, then and only then she can marry. Otherwise, she cannot marry. Okay. To do the branch coverage, what I need is I need to actually cover this particular case and any one of these three cases to cover the true side and false side of the decision. This is my decision coverage or branch coverage. Condition coverage says you cover all of it. What this means is if I have done my condition coverage, my branch coverage will automatically be complete, and if I have done my branch coverage, my statement coverage will automatically be complete. Okay guys, why you need to have these code coverages? Because typically at the black box level, we don't touch 75% of the code. For example, a lot of exception handling is never touched. a lot of code which is written for a lot of other things is never touched when you're doing only a black box kind of testing. So white box and black box, they are complementary to each other, both should be covered. It is not that only white box or only black box is enough. The third technique that you use is, or design technique that you use, is experience-based technique, which is based on skill and intuition, which is based on experience with similar applications or similar technologies. For example, whenever I start testing in a new project, the first number I use to test that application is 666, 666. If you have seen Omen, which I saw when I was a very small kid, I knew that this is a devil's number, and I always use devil's number to start with my testing. I don't know why, don't ask me why, but I use this. I have an intuition that I'll get bugs with this 6, 6 and 6. It is not that I always get them, but now this is more of a ritual for me to start with 666. So based on my skills, based on my intuition, based on my experience with applications and technologies, based on how exposure you have got with experience kind of testing, if you're context driven kind of person, if you have ever heard Pradeep Soundarajan or James Bach or Ken Kenner, or if you have gone through the books of these guys, you might know that these are people who have been very, very successful using this experience-based testing. Tests mostly are time boxed here. So what you have is you can use session-based test management or something like this to make sure that your objectives are getting covered. Experience-based approaches can be checklists, can be bug taxonomies, can be hunt approaches, can be charters that people have written, can be anything, depending again on your experience. This is entirely your experience and your way of handling things. You can use this technique based on how you do it. Purely on the fly kind of testing is common, but these days people are putting it into a proper structured way of doing exploratory testing, and SBMT is one of the best examples for this. Advantages of exploratory: very good at finding defects, very effective because there is not enough record keeping. They are fun, they are creative, but there are few disadvantages because people are not experienced with these techniques, so coverage becomes gappy. Very, very difficult for managers to estimate. There is no bug prevention, only the bug detection kind of thing, and not all testers have necessary level of skill and experience. So you must get trained properly before you really go into experience-based testing. There is a study which says that there was 7 technicians with less than 10 years of total experience. Their effectiveness was only 22, while there were 3 engineers and 1 manager where total experience was more than 20 and their effectiveness was 44. This is just a case study which tells you that exploratory testing might give you more effectiveness than a scripted kind of testing. And the last thing, what factors when you are choosing any technique? The typical factors will be what kind of system you are talking about, regulatory standards, contractual requirements, time and budget, your development life cycle, knowledge of your testers, what kind of teams you have. These all will be different factors in choosing your test techniques, what kind of technique you are going to use. I think with this we have covered. What I'll do is I have 5 or 10 minutes. Okay, so we have 10-15 minutes. So what I'll do is I'll give you my email IDs. Even after the session is over, you can contact me on all this, and by that time, let's see if there are any questions from participants. Okay. Okay. So let me start with the first questions that we got. Okay. There was a question right at the start by Vaibhav. What are the main criteria set for the finalization of design if the requirements get changed frequently or the company not maintain documentation for requirements? Vaibhav, if your requirements are getting changed frequently, then the idea is that you, as I told you, you follow a risk-based estimation, and you can keep changing that risk document. I have shown you FMEA, which is very easy to maintain. There will be some time that you might have to invest at the start, but once your basic set is ready with that FMEA, then it is very easy to keep changing things. So you know, okay. So I think this gives your answer that if there are requirements which are changing very frequently, you can follow a particular strategy so that your designs don't miss. Chetan has asked how much test data required for testing. Chetan, my dear friend, very difficult question, because you can use a single set of test data and you can create millions and millions of test files. Depends on the context of the system. Okay, so it is very difficult. Okay, okay. Syed has asked that can you elaborate quality risk? Syed, I showed you the slides which were covered by where we covered the informal way of finding the quality risk categories, or where I have used FMEA and all those approaches. Quality risk is what risks you have to your system or software, and thus you can use any of these techniques to find the quality risk categories. Okay. Okay, the next question. Okay, Ganesh has asked a very good question. It says, can we apply boundary value analysis even for scenarios where we do not deal with numbers? Ganesh, I think I gave you an example with the alphabets where you have a text box on the screen. I gave you example with the printer. So it is not only the numbers, but any time when the behavior of the application changes, you can use this boundary value analysis. So it depends, it depends on your understanding of the system. Okay, Kushal has asked for the Delhi temperature 0 degree question. Kushal, I asked that if today's Delhi temperature is 0 degrees Celsius and tomorrow is going to be double cold, what will be the temperature tomorrow? 0 degree double is 0, so you cannot find the answer here, but then you have to convert 0 degrees Celsius into degrees Fahrenheit, find the half of what that number of Fahrenheit will come, and then you can convert that back into degrees Celsius. Pooja asked how to apply equivalence partition rule with non-numeric inputs. Pooja, it again depends. For example, if you have, say, all the character sets, you can have all the, for example, you can print all your documents in a particular driver using, say, PCL6 driver or anything. You can put them in one equivalence set, or you want to check the time, or you want to check the print, or you want to check the font. Say Arial font can go into one set, any other font can go into another set. So it depends on how you do this equivalence partitioning. Again, if the output for everything is same, you can put them into one equivalence partition. Can we apply BVA to saving notepad functionality? The question by Ganesh again, I think. BVA to saving notepad functionality, boundary value analysis to saving notepad functionality. I don't think I should now answer this, but just giving you a hint of it. Saving a notepad for certain text file size, you can definitely use BVA. Okay, I hope Ganesh got an idea of what I'm talking about. Okay, Gaurav has left, but he asked a very good question. Should the unit test cases be part of decision table? A decision table is a black box technique, while as unit test cases are part of white box technique. So again, if you have very good understanding of decision tables, you can surely use them. But if you don't have, then keep decision tables and unit test cases separately. Okay, Mrinal has asked, is decision table always required for all features and scenarios? No, Mrinal, I don't think decision table is always required. It is up to you. It depends on the context of the software. It depends on the relevance of the software, and depends on whether you can really create a decision table or not. So it is not always required. If you can cover it, yes, you should create it, but not necessary for all the features and scenarios. Shailendra has asked a very good question: when to stop testing the project? I want to know the general criteria. Shailendra, when the cost of conformance meets cost of non-conformance at an optimal level, you stop testing. To know more about it, mail me. Do test estimations play a role during test analysis stage? Asked by Priyanka. Yes, Priyanka, estimations play a lot of role during analysis because you have to estimate for your analysis as well. Second, your estimate will tell you how much in depth you have to go using these test techniques, how much in depth you have to write your test cases and all that. So yes, estimation plays a role in test analysis. Ashish says, I don't agree on username and password with you. There can be a case with invalid username and valid password. My dear friend Ashish, how can you find a valid or an invalid password for a username which is invalid? You are saying that you can go to a ATM and you can use an invalid card and you can check the validity of PIN. My dear friend, not possible. Invalid username and password. Anyways, username and password together makes a unique key for the login table. If any one of them is invalid, you really don't need to check the other one. So if you need to know more about it, email me and I'll give you an answer on this. Again, if username and password are case sensitive, Ashish, mail me and we can discuss this more. Or the people who are really interested in knowing it, mail me and we can discuss this more. Okay, Govind says how test analysis is white box, is in white box. Govind, this is not test analysis, this is test design. We were discussing about test analysis and design in this, and white box testing, the techniques that I have shown are part of test design techniques. Okay. Who should write the use cases? Anybody who is good in writing. Sujay Kumar Bose has asked this. Who should write use cases? Sujay, anybody who is good in writing requirements can write use cases. Tester, developer, architect, anybody. Krishna Kumari says, can you please share this presentation? I'm so sorry, I cannot share any soft copies with you. They all are copyrighted. So I don't have the authority to share any soft copies. We can find out, the way to share the hard copies. So mail me and we can, talk about it. Vineet Kumar has asked, what are different dynamic test strategies? Vineet, test strategies entirely is a different topic. So if Bharat runs a session on test strategies, they can discuss about it. Pramod says ISO 91 talks about mostly functionality and usability. Is there any standard about performance and security aspects as well? Yes, Pramod, there are many standards. If you go through IEEE standards, then there you will find some performance and security aspects as well. Then there are many other standards in the world. If you talk about ISTQB or QAI or many other, people talk about these performance and security related issues. Performance and security in any ways is becoming a big thing for software. I think I have run short of time now. I only have 2 or 3 minutes remaining. So I'm very sorry for the questions I was not able to take up. Okay, there are many that I can see. I have around more than 300 questions. Guys, I'm very sorry I'm not able to take all the questions. Here are my email IDs, my Twitter handler. I am also on Facebook and LinkedIn. You can find Ramit Manohar on Facebook and LinkedIn and you will definitely find me. You can Google my name Ramit Manohar and you will find my links for Facebook and LinkedIn. You can ask me questions on any of the mail IDs if you can see them. For the people who cannot see the screen for any reason, you can note down the email IDs. Ramit M. Kaul, that's RAMIT, Roger Alpha Mumbai, Internet Technology Mumbai, Kashmir Alpha Uranium and L London at gmail.com. That's Ramit M. Kaul at gmail.com. You can also mail me at Ramit_Manohar at Dell.com or you can use Ramit at IndianTestingBoard.com. My Twitter handler is @Ramit I told you, you can find me on Facebook and LinkedIn with the name of Ramit Manohar. Thank you very much, guys, for listening this. I appreciate it a lot. Back to Bharat.
Thanks, Ramit, for your session on test analysis and design. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be made available to you on techgeek.com by tomorrow. So see you all next Tuesday, that is September 27th at 3 p.m. in our next session on test execution and reporting by Mr. Ashu Chandra, Head of Testing Services at Infogain. Thank you.